Want to become like Sundar Pichai, Satya Nadella or Narayan Murthy? Then you need to go for B.Tech, that is Bachelor of Technology, or in simple words, study engineering. So what exactly is a B.Tech? The Bachelor of Technology is awarded to students who complete their engineering studies over a span of 4 years. It's one of the most sought after programs for those wanting to become engineers. B.Tech programs focus on the practical and application oriented aspects of engineering, training students to apply theoretical knowledge in solving real world problems. If you are aiming for a B.Tech, it's crucial to focus on certain subjects during your school years. The most important subjects are mathematics, physics, and chemistry. In fact, most B.Tech entrance exams are based on these three subjects. Strong problem-solving skills, logical thinking, and a solid understanding of these topics will prepare you well for B.Tech courses and entrance exams. Now let's talk about the specializations available in B.Tech. There are numerous branches that you can choose from depending on your interests. There are institutes that offer certain specializations that are not in much demand. We have tried covering all the courses. Here goes the list. Computer Science and Engineering focuses on the design, development, and maintenance of software systems, programming languages, and algorithms. This is one of the most popular streams due to the growing demand in the IT sector. You can become a software developer, data scientist, AI machine learning engineer, system architect, database administrator, cybersecurity expert, game developer, or a cloud computing specialist. Then comes Information Technology, a specialization that deals with managing and processing information through computers, networks, and telecommunications. As a career, you can become an IT consultant, network administrator, web developer, cybersecurity analyst, system analyst, database manager, and a cloud engineer. Mechanical Engineering covers the design, analysis, and manufacturing of mechanical systems such as engines, machines, and tools. Mechanical engineers work in industries like automotive, aerospace, and robotics. You can become an automotive engineer, robotics engineer, manufacturing engineer, maintenance engineer, product design engineer, aerospace engineer, and a thermal power engineer. Electrical Engineering involves the study of electrical systems, circuits, and devices. This field plays a vital role in power generation, electronics, and telecommunication industries. You can become an electrical engineer, power systems engineer, control systems engineer, telecommunications engineer, electronics engineer, electric vehicle engineer, or an instrumentation engineer. Electronics and Communication Engineering focuses on the design and developmentation of electronic devices, circuits, and communication equipment such as mobile phones, television, and satellites. Career tracks include Embedded Systems Engineer. An embedded system is a combination of computer hardware and software designed for a specific function. An embedded systems engineer is responsible for designing, developing, and managing embedded systems in products. They work collaboratively with developers and provide technical assistance to clients and other departments. Embedded systems engineers also create and maintain documentation of projects and procedures. Then you can become a telecom engineer, VLSI design engineer. A VLSI engineer, a very large-scale integration engineer, is a highly specialized professional who focuses on the design and development of integrated circuits. These circuits, often referred to as chips or microchips, are the brain power behind countless electronic devices. VLSI engineers work on a spectrum of tasks within this domain, ranging from logic and analog circuit design to the intricacies of semiconductor fabrication. They are the masterminds behind the continuous miniaturization and enhancement of electronic components that power our modern world. And you can become a signal processing engineer. A signal processing engineer is an information technologies expert that analyzes and alters digital signals to make them more accurate and reliable. As a signal processing engineer, your responsibilities are to develop, manage, and update digital signals, creating algorithms to process them more efficiently. Then you can become an RF engineer. An RF or radio frequency engineer is responsible for designing, implementing, and maintaining wireless communication systems. Their primary role is to work with devices that transmit or receive radio waves such as mobile phones, radios, and satellite communication systems. Then you can become a communication systems engineer and a network engineer. Civil engineering deals with the design, construction, and maintenance of infrastructure like roads, bridges, dams, and buildings. Civil engineers work in both public and private sectors, helping to develop essential infrastructure. Career tracks include structural engineer. A Structural engineers ensure that buildings and bridges are built to be strong enough and stable enough to resist all appropriate structural loads, example gravity, wind, snow, rain, earthquake, earth pressure, temperature and traffic, to prevent or reduce the loss of life or injury. Then you can become a construction project manager, a geotechnical engineer. As a geotechnical engineer, you will access the physical, mechanical and chemical properties of soil and rock in order to design foundations, retaining structures and earthworks. Your assessment will enable you to determine the feasibility of a construction or engineering plan. Then you can become an urban planner, transportation engineer, environmental engineer, or a surveyor. Chemical engineering involves the study of chemical processes and the production of chemicals, fuels, drugs, and food. Chemical engineers work in fields like pharmaceuticals, petrochemicals, and material science. You can become a process engineer, petroleum engineer, pharmaceutical engineer, biochemical engineer, energy engineer, materials engineer, or a food processing engineer. Then comes biotechnology. This interdisciplinary branch combines biology and technology to develop solutions in healthcare, agriculture, and the environment. Biotech engineers work in genetics, bioprocessing, and pharmaceuticals. Career tracks include biotech research scientist, genetic engineer, biomedical engineer, pharmaceutical researcher, clinical researcher, agricultural biotechnologist, or an industrial biotechnologist. Aerospace engineering focuses on the design, development, and testing of aircraft and spacecraft. Aerospace engineers work in the aviation and space exploration industries. You can become an aircraft designer, aerospace engineer, avionics engineer. Avionics engineers conduct research and solve developmental problems associated with aviation, such as instrument landing systems and other safety instruments for aircraft or space vehicles. You can also become flight safety engineer, aerodynamics engineer. Aerodynamics engineers or aerodynamicists study the impact of gases, including air, on different objects and the forces that this contact creates. These individuals use their aerodynamics knowledge to help design efficient, environment-friendly aircraft, vehicles, and structures. Then you can also become a spacecraft designer or a defense system engineer. Automobile engineering, specialized in vehicle engineering, design, and manufacturing. This stream is key for those looking to work in the automotive industry, focusing on both production and R&D. You can become an automobile designer, vehicle dynamics engineer, manufacturing engineer, motorsport engineer, automotive quality engineer, or an automotive systems engineer. Then comes agricultural engineering. This branch applies engineering principles to agricultural production and processing, dealing with irrigation systems, farm machinery, and food processing. You can become an agricultural machinery design engineer, irrigation engineer, soil and water conservation engineer, food processing engineer, agricultural researcher, farm manager, or an environmental control specialist. Biomedical engineering combines engineering with medical sciences to develop healthcare technologies like medical devices, diagnostic tools, and artificial organs. Career tracks include biomedical equipment technician, clinical engineer, medical device developer, rehabilitation engineer, where you will be involved in designing artificial body parts and improving the function of artificial limbs. In this area of healthcare science, you will provide standard and custom-made assistive technology, including special seating wheelchairs. Then you can become a Bioinformatics Specialist. Bioinformatics Specialists collect, manage, and study biological, especially DNA and biochemical data at the molecular level by using computer software and hardware. They also design computer databases and develop complicated mathematical formulas called algorithms to study and manage data. Then you can go into research and development in medical technology or become a biomaterials developer. A biomaterials engineers apply their knowledge of engineering and biology to design, develop, and test health systems and products. Implantable devices like pacemakers, defibrillators, and artificial joints must be biocompatible while carrying out complex chemical, mechanical, and electrical functions. Petroleum engineering focuses on the exploration and extraction of oil and gas. Petroleum engineers work in oil fields, refineries, and research labs to optimize the production of hydrocarbons. You can become a reservoir engineer, drilling engineer, production engineer, petroleum geologist, oil field services manager, pipeline engineer, or an energy analyst. Then comes mining engineering, which involves the extraction of minerals from earth, covering the planning, development, and operation of mines. Mining engineers work in mineral extraction, resource management, and mine safety. Career tracks include mine engineer, mineral processing engineer, mine safety engineer, environmental consultant in mining, exploration geologist, mine planning engineer, or a blasting engineer. Environmental engineering focuses on protecting the environment by developing technologies to treat waste, reduce pollution, and manage natural resources sustainably. Career tracks include environmental consultant, water resources engineer, air quality control specialist, waste management engineer, sustainability specialist, pollution control engineer, or a renewable energy specialist. Textile engineering involves the design and development of textile materials and technologies used in clothing, industrial fabrics, and home furnishings. You can become a textile designer, production manager in textile technologists, quality assurance engineer, research and development engineer, or an apparel production engineer. Marine engineering specializes in designing, maintaining, and operating ships and other sea vessels. Marine engineers are involved in shipbuilding, maritime transportation, and offshore exploration. Career tracks include marine engineer, ship designer, port and harbor engineer, offshore engineer, marine surveyor, submarine engineer, or a naval architect. Then comes industrial and production engineering, combines engineering principles with business practices to optimize manufacturing processes, improve production efficiency, and manage resources in industrial operations. You can become a production engineer, manufacturing systems engineer, operations manager, quality control engineer, supply chain analyst, process improvement engineer, or a lean manufacturing consultant. The lean manufacturing consultant helps to monitor and control processes that meet demand fluctuations, minimizes necessary waste, while at the same time works at eliminating unnecessary waste. Metallurgical engineering focuses on the extraction, refining, and development of metals and alloys. Metallurgical engineers work in industries like steel, automotive, and aerospace. You can become a metallurgist, materials engineer, steel plant engineer, welding engineer, corrosion engineer, quality control engineer. Then comes instrumentation engineering, specializes in the design and development of instruments used in measurement and control systems. Instrumentation engineers work in fields like manufacturing, energy, and automation. Career tracks include instrumentation engineer, control systems engineer, automation engineer, process control engineer, field instrumentation engineer, measurement and control engineer, and instrumentation design engineer. Then we move to materials science and engineering. It involves the study of materials and their properties to develop new products and improve existing ones. This field is crucial in industries like aerospace, electronics, and nanotechnology. Career tracks include materials scientist, Nanomaterials Engineer. And Nanomaterials Engineer is a specialized engineer who designs, develops, and manipulates materials at the nanoscale, that is 1 to 100 nanometers. Their primary focus is on engineering materials with unique properties that emerge when working at this extremely small scale, which is much smaller than the thickness of a human hair. These engineers work with substances such as carbon, nanotubes, nanocomposites, nanoparticles, and quantum dots to create new materials that have enhanced or completely new physical, chemical, electrical, or optical properties. Then you can also become a polymer engineer, composite materials engineer. Composite materials engineers utilize composite materials such as resins, carbon fiber composites, and glass fiber based materials to design structures and buildings. Composite materials are made by combining two substances with different properties that when put together produce a more durable substance. Then you can also become a ceramics engineer, where you deal with science and technology of creating products using non-metallic inorganic materials like clay, glass, refractories, ceramics, and composites. Then you can also become a research and development engineer or a metallurgical engineer. Mechatronics engineering, a multidisciplinary field combining mechanical, electrical, and computer engineering to develop automated systems and robotics. Career tracks include robotics engineer, automation systems engineer, control systems engineer, machine learning engineer, industrial automation engineer, mechatronics design engineer, or an IoT engineer. Then we move to food technology, which combines engineering and biology to develop processes for the production, preservation, and distribution of food. You can become a food processing engineer, quality control officer, food safety auditor, product development specialist, R&D specialist, supply chain specialist, or a production manager. Then we move to robotics engineering, which specializes in the design and development of robots and automated systems for use in industries like manufacturing, healthcare, and defense. Career tracks include robotics programmer, robotics engineer, automation engineer, AI and robotics researcher, mechatronics engineer, industrial robot specialist, or a robotic systems integrator. Nanotechnology focuses on the manipulation of materials at the atomic and molecular level to create new materials and devices with unique properties. Nanotechnology has applications in medicine, electronics, and energy. You can become a nanotechnologist, nano-engineer, material scientist, research scientist in nanomaterials, biotechnology and nanotechnology researcher, semiconductor process engineer, or a nano device engineer. Then comes ceramic engineering. It involves the study and production of ceramic materials used in industries like electronics, construction, and aerospace. Ceramics engineer work on developing materials with unique heat resistance, strength, and electrical properties. Career tracks include ceramic technologist, materials engineer. Refractories are ceramic materials designed to withstand the very high temperatures. A refractory technician designs high temperature equipment and heating structures using heat-resistant elements such as mineral, ceramic, and brick components. Then you can also become a glass technologist, research scientist in ceramics, ceramic manufacturing engineer, or a ceramic product designer. Then comes polymer engineering. It focuses on the design and development of polymer materials like plastics and rubber, and their applications in industries like automotive, packaging, and healthcare. You can become a polymer engineer, plastics technologist, material scientist, product development engineer, quality assurance engineer in polymers, polymer chemist, or a research and development engineer. Power engineering deals with the generation, transmission, and distribution of electrical power. Power engineers work in power plants, renewable energy systems, and energy management. You can become a power systems engineer, grid engineer, energy analyst, renewable energy specialist, transmission engineer, power plant engineer, or an electrical network planner. Then comes railway engineering. It specializes in the design and construction of railway systems covering track infrastructure, signaling, and rolling stock. Career tracks include railway engineer, track design engineer, rolling stock engineer. A rolling stock engineer designs and oversees the manufacturing process and installation of rail vehicles. This includes locomotives, carriages, wagons, and multiple units. Rolling stock engineers design new trains and electrical or mechanical parts, supervise modifications, and resolve any technical problems. Then you can also become a signaling engineer, transportation planner, rail infrastructure engineer, or a train operations manager. Last but not the least is structural engineering, a specialization with civil engineering that focuses on the analysis and design of structures like buildings, bridges, and tunnels to ensure they can withstand loads and forces. You can become a structural engineer, bridge engineer, building consultant, construction project manager, seismic engineer, structural analysis engineer, or a steel structure designer. You might have heard about another degree similar to B.Tech, the BE or Bachelor of Engineering. It is confusing for some, so let me clear out the problem. BE courses focus more on theory and strong fundamentals, whereas B.Tech courses focus more on practical applications. Usually, the BE engineering degrees are given by universities that provide degrees even in the other streams like arts, humanities, commerce. Some of the famous institutes providing BE degrees are BITS Pilani, Anna University, whereas some of the very well-known engineering institutes like the various IITs and ITs, which are classified as institutes of national importance, provide B.Tech degrees. For BE, curriculum internships and industrial visits may be an essential part of a curriculum, but for B.Tech curriculum internships and industrial visits are mandatory. BE is more knowledge-oriented, whereas B.Tech is more technology-oriented. There may be a possibility that BE degree courses are not as frequently updated as B.Tech courses. However, this degree does not conflict with the rules of the AICTE. But on the other hand, B.Tech courses are frequently updated as per the latest developments in the respective field. The AICTE, which is the All India Council for Technical Education, does not consider either BE or BTech as different courses. Hence, equal recognition is granted for both of them. In terms of job opportunities in the market, students having either a BE or BTech degrees have equal opportunities and have equally good scope. It is in no way going to be a hindrance to good career growth. Choosing the right college can make a big difference in your BTech journey. According to the latest NIRF rankings, here are the top 10 engineering colleges in India. First comes IIT Madras. At number 2 is IIT Delhi. Number 3 IIT Bombay. Then comes IIT Kanpur, followed by IIT Kharagpur, IIT Roorkee, IIT Guwahati, IIT Hyderabad, and IIT Trichy. And at number 10 we have IIT BHU. Apart from these, there are other good private colleges in India like BITS Pilani and VIT Vellore. These institutions are known for their excellent faculty, cutting-edge research and fantastic placement opportunities. To get into these top BTech colleges, you'll need to clear some of the most competitive entrance exams in India. The major ones include JEE Main, conducted by NTA. It is the gateway to most NITs, IITs and some private universities. Then there is JEE Advanced, which is the secondary level of JEE Main. If you clear the cutoff in JEE Main, you are eligible to appear for JEE Advanced, which gives you admission into the prestigious IITs. Then comes BITSAT, which is the entrance exam for BITS Pilani and its other campuses. Then we have VIT EEE, conducted by VIT for admission into their BTech programs. Then comes SRM JEEE, which is the entrance test for SRM Institute of Science and Technology. And then there are state level exams like MHT CET for Maharashtra, WBJEE for West Bengal and Comet K for Karnataka. Lastly, let's take a look at some important data from the AISHE report 2021-22. Engineering and technology has 39 lakhs enrolled students, out of which 29% are female and 70% are male. Around 11% of the undergraduate students are pursuing BTech, including BE. That brings us to the end of this video. I hope you found this information helpful. If you have any questions or want to explore a specific specialization further, feel free to drop your comments below. Don't forget to like, share and subscribe to Beyond 12 for more in-depth guides. See you in the next video.